Good evening, ladies and gentlemen. I'm Ben. I'm the chair of the Friends of the DAO, and it's my pleasure, as always, to introduce, well, it's an easy job to introduce someone who doesn't need any introduction. Before I do that, I would like to acknowledge that we're on the territory of the Senchothan-speaking peoples, and you are on the mountain they call the Tixas. Bob, of course, is one of the country's best-known science journalists, and he's been bringing science to the public for more than 40 years, originally from the other place that calls itself the center of the universe. I think it starts with T. He's the host of Quirks and Quarks, the award-winning science program with a national audience of 500,000 people. I know I'm one of them. Anyway, Bob holds 12 honorary doctorates. They're much easier to get than the written and the other kind. But from Canadian universities and 2 honorary degrees. He is one of our fellow board members, and he's been very supportive of outreach up here. When we first started up the Friends of the DAO, Bob agreed to help do some of the grunge work of clearing out the center and taking the inventory. And he'd never been in this building before. Of course, he'd been in the Plaskett Dome getting awards and things like that before that, but he immediately saw the opportunity that we had to extend public outreach in this center, and we're very grateful for all the help he's given us over the years and all the work he's put in. So without further ado, here he is.
Thank you very much, Ben. Hi, thank you, everyone. So wasn't it exciting seeing the SLS take off today? Not. I've never been a fan of this rocket, and I'd like to tell you why tonight and why I call it the Frankenstein rocket. It is made of used space shuttle parts. It has been in development since 2010. It was supposed to fly in 2016. So it's 5 years late. They have spent $23 billion on it so far. And just to put this into context, the 12 years that they've been working on this one rocket, the entire Apollo moon mission program, from the time Kennedy said, we choose to go to the moon, not because it's easy, but because it's hard. From there to the very last mission in 1972 was 12 years, less than 12 years. So we went to the moon 6 times. With 17 rockets that were made in the time it took to get this off the ground once. Something is wrong here. I'm not sure why. I'm not going to go into
Didn't get
why.
it off the ground once.
But
Didn't get it.
Well, part of it did. I'll get to that. Part of it did. Anyway, so how did we get to all of this? Well, let's go back to that Kennedy announcement when he said we're going to go to the moon, and they had to build this amazing big rocket. And he knew that it was going to cost billions of dollars. And in the end, it cost about 24 billion. In our money today, that's about 250 billion to go to the moon, which is a lot. And he knew that the only way he could get the government to support that, to get Congress and the Senate to support that, was to involve every state in the union. And in the end, 400,000 people worked on the Apollo mission. 400,000 people. That's incredible. It was a make-work project. It was also why it was so expensive, because all these parts are being made in different parts of the country, and then they all have to be brought to the Kennedy Space Center, stacked on top of one another and work. And it's amazing they did. It's amazing they did. They did that. So after the moon program, they thought, well, you know, this is crazy because these rockets were disposable. They only used them once. They only used them once. And think about this gigantic rocket, especially the first stage, with these big engines that produce 7.5 million pounds of thrust to lift this gigantic rocket off the pad straight up and push it through the sound barrier and get it going up into the atmosphere so fast at the edge of space. That first stage had a lifetime of 2 minutes, 135 seconds. Just over 2 minutes. Then it ran out of gas while it was still within sight of the launch pad. And what happened to it? They detached it and it dropped into the Atlantic Ocean. And in fact, just a few years ago, they found one of these engines lying on the bottom of the sea. And I've often thought that if you could go to Florida and make the water disappear just for a few hours, you would see thousands of rocket bodies lying on the bottom of the ocean, because that's where they ended up. All these military rockets and the early space program rockets, they were only used once and thrown away. Well, that's crazy. So they said, okay, let's not do that anymore. Let's design a spaceship that can be reused. And hence we come to the space shuttles, which we're all familiar with. So here we have a rocket and an airplane that takes off right after launch. These two big solid boosters here break off. They were necessary because rockets are really expensive on fuel. So it's got these three big engines, not as big as the Saturn V, but still pretty powerful. And most airplanes carry their fuel in the wings. But the wings on this aren't big enough, so that's why they had to put this big fuel tank of liquid hydrogen and liquid oxygen on it. But then it was too heavy to fly. So they had to put the boosters on the side just to get it off the ground. But again, the boosters, they only lasted for 2 minutes. Then they were dropped into the ocean, but they were picked up by ship and used again, refurbished. So then they get up into space and this part comes off. The only part that was thrown away was the big tank, and it ended up in, I believe, the Indian Ocean, where it would burn up in the atmosphere. And then this thing's up in space. They opened it up. They carried cargo. They had the Canadarm here in it. Very nice. That was our contribution. Yeah, yay, Canadarm. And it built the International Space Station. It took all of our Canadian astronauts up into space. Really great. Then it would come and land back down, take off. When this was first being proposed, they were saying this thing is going to be so regular that it'll be taking off every 2 weeks. That never happened. That never happened. Because they found every time it came back, it needed to be refurbished so much. And tiles were falling off and all kinds of things. In fact, towards the end of the program, whenever one landed, engineers would go in and they start ripping out parts to put it in the next one that was sitting on the launch pad, because they had to recycle parts to keep these things going. And in the end, these actually ended up costing about $1.5 billion every time they took off. So they didn't meet the original promise. They were functional, most complicated machine to ever fly, and a remarkable machine. And you can now see these in museums. There's one at the Kennedy Space Center. There's one in California at the Science Center. There's one in Washington, and there's one in New York. And do it. Go see them. You can get right up close and see just how big these things really are. They're really large, amazing spaceships. During the shuttle program, there was actually an idea of what if we don't use that instead of hanging this 100-ton airplane on the side of the rocket of the tank. Why not just use this as a heavy-duty, heavy-lift vehicle? And you take some of the shuttle engines and put them on the bottom here, and then you can put another rocket on top. And that was called the Constellation program. So that was the idea. Constellation. And they were going to take one of the solid boosters and put an extra booster on top of that, and that's where you would carry the people. The Orion capsule that harkens back to the moon missions of just a small capsule that doesn't have wings. And they actually flew the Ares, they called it the Ares. They did one flight just to prove that they could do it. Then the Obama administration came along. And they said, you know, it's still the same contractors building this as built the space shuttle. It's still going to cost $2 billion every time you fly. This is nuts. Why don't we let the private sectors do it? Why don't we sponsor companies like SpaceX, which we have since seen has shown that they can build their own rockets. Instead of having the whole country involved in building a rocket, they do it all under one roof. They build the engines, they build the rocket, they build the capsule, and they fly them. And they have shown that these Falcon 9 rockets are 10 times cheaper than what it was costing to go up in shuttles. And they're reusable. They're reusable. They can also take people in space. In fact, the Artemis now is delayed, and one of the reasons that it's going to be delayed, I think they're going to have to roll it back to the vertical assembly building to fix this hydrogen leak, is because there's a Dragon going up in another week or so. So they have to let that. So SpaceX is going while Artemis is not. So they're going to be taking people up to the International Space Station. They also have another one where you put 3 Dragons together. It's called Falcon Heavy. And this one launched a couple of years ago, and Jennifer and Jacob and I were there for that. We saw this launch. And what was amazing about it, not so much the launch itself, but it was the landing, because these boosters come back. Oh yeah, and Elon sent his car into space. On the very first flight of this heavy duty rocket, he sent a car out to the orbit of Mars. Out to the orbit of Mars on the very first flight. This giant Artemis is only going to go to the moon. Elon went to Mars on his first flight, and that car's still out there. I wonder what it looks like now. And who's in that spacesuit? Let's send grandma off. Listen, what a funeral. I don't know. Anyway, but that was just a demonstration of how powerful that rocket is. And Falcon Heavy could go to the moon, and it will be going to the moon in the future. So they've already done that. But what was amazing was watching the landing of these boosters. They came down by themselves, and you're out there and you're looking up into the blue sky. You don't see anything. And then all of a sudden, these two starlight bright lights appeared in the sky, and it's their engines. They just fall out of space. And as they're coming down, they fire the engines just a little bit to slow down. And then you look up and you see what looked like two big white logs falling out of the sky. And they're coming down sideways. They're just falling out of the sky like this. It looks like there's no control at all. And then at the last second, the engines fire again. They straighten up and they just come down and they land in perfect synchrony. And there's no hesitation. There's none of this like a helicopter, comes down looking for the landing spot, hover a bit, and then do this. They just come, stop. It's unbelievable. And SpaceX has now reflown some of these rockets more than 10 times. So SpaceX knows how to do it. Obama was right. The private sector can do it. However, back in 2010, all of those senators and all those congressmen from the government said, hey, wait a minute. What about all those jobs? We're losing jobs. You can't do that. We're losing jobs. Get this thing going again. So that was when Artemis was born. That was when Artemis came back and what we have today. So that was 2010. And SpaceX, meanwhile, is building another rocket called Starship, which is bigger than all of them. And it's now getting ready to fly. And it's down in Texas on the Gulf Coast. And this thing, Elon says this is not only going to go to the moon, it's going to go to Mars. So they're already building a bigger rocket than Artemis. But Artemis is back with the whole country involved in it, thousands of countries. So you could say it's great for jobs. It's great for jobs. But as far as going into space, it's a very expensive way to do it. And in fact, the Auditor General of NASA looked at Artemis and said, it's not sustainable. It's going to cost $4 billion every time it takes off. And it'll only fly once a year. So it's going to be interesting to see if this gets off first. They're testing it right now. So here we are with this Frankenstein rocket. The engines that are on the bottom are used space shuttle engines. They've already flown in space. They're used engines. And the rockets, the solids have been refurbished. So how is it that this thing out of the 1980s, which is when the space shuttles were built, is being used now, and it's still 12 years late? Well, anyway, I just don't get it. So what's going to happen? If this thing gets off, it now looks like it's going to be next month because they were having problems with hydrogen. The hydrogen fuel that they use, it's really nasty stuff. It's minus 252 degrees Celsius. That is so cold. It's still a liquid. It's still a liquid, but it's super, super cold. So anything it touches, it's going to freeze. So valves get frozen up. Or if it hits metal, the metal will shrink, and that can cause gaps, which I think is what's been going on here. They have leaks with it. And they have to cool the engines down ahead of time to that temperature so that the liquid doesn't cause, expansion and cracks and all that. Or the liquid itself would boil. If it hits a warm pipe, it'll turn into a gas and you get expansion. So it's really, really hard to deal with liquid hydrogen, which is what they're trying to do here. It does give you a better thrust, but it's a nasty fuel to deal with. So we'll see. We'll see. It will fly. It will fly. And what's it going to do? Well, it's going to go to the moon. It is not recyclable. The whole thing is thrown away. Even the solid boosters that used to be recycled are not. They're going to be thrown away on this mission. The only part that comes back is the little capsule at the top. I had to laugh. They've been trying to say, yeah, we're going to recycle. During one of the press conferences last week, an engineer from, I think it was Boeing or something, they said, well, we're going to recycle. We're recycling the batteries and the seats. Great, great. You buy a new car, you drive it until it runs out of gas, and you save the seats and the battery. And the next time you want to drive, you got to buy a new car. Great, that's what we're doing. And it's going to go into what's called a halo orbit around the moon. This is an orbit where you're always in sight of the Earth. Instead of going around this way, you go around kind of like that. It's a very long, loopy orbit. It's going to take about 6 weeks. They want to test everything out and then come back. There's a lot of conditions. You hear about launch windows. You've got to go at just the right time. You don't want to go when the sun, the Earth, and the moon are all in one line, because you'll be going down the shadow of the Earth. It'll be like an eclipse. And the spacecraft is solar powered. It needs to see the sun. So you got to go when the sun, the Earth, and the moon is either over here or over here. So the moon goes around every month. So you got to wait for that. Then when you get to the moon, you want to make sure that the sun is at a bit of an angle over here. You don't want it straight overhead, because it washes out all the details, just like in a telescope. You want the sun at an angle so you can see the ground, see shadows. And then you got to make sure that the Pacific Ocean is facing you when you come back. The Earth's turn every 24. So you got an Earth turn every 24 hours, a moon going around every month, and then we're going around. It's very complicated. Plus, there's other traffic. You don't want to hit anything on the way up. So it's very, very complicated. That's why these launch windows only come along once in a while. What are they going to land on? The third mission is supposed to be a landing. And NASA put out bids for a lander to go from orbit down. And who won the bid? SpaceX and their Starship. That's what's going to be taking people down to the moon. So why do we need Artemis if Starship's already going to do it? I think Artemis will be taking cargo. It'll be taking cargo, and SpaceX will be taking people. It's going to be bizarre because they sit way up near the top, and this thing lands in one piece. So they're going to have some kind of elevator or, I don't know, crane or something to get them down to the surface. But anyway, that's the plan. Where are they going? They're planning to go to the south pole of the moon. You've probably heard that there's water ice down there, because there are craters at the bottom of the moon that never see the sun. The sun never shines over the rim. There's one in particular called Shackleton. So they're going up the bottom of the moon where the sun don't shine, is where they're going. So there's a bunch of them down there, and they think there's ice. Ice is a resource. It's water. It's hydrogen and oxygen for fuel. So they want to do some prospecting there. Before they go there with people, there's also a mountain that is sticking up, Melpert or something like that. I can't remember. This mountain, the sun always shines. So it sticks up high enough that the sun goes around the horizon like this at the South Pole. So it's always sunny. So that might be a landing spot. So they go from permanent sunlight to permanent darkness, which also means an incredible temperature difference. Because on the moon, when you're in the dark, it's super cold, very, very cold. And the dark is pitch. It's not like here, you go outside at night, the sky still reflects a little bit of light and it bounces around, you can see in the dark. You don't on the moon, it's black. So they're going to send a rover called Viper. It's going there first. Viper stands for, let me see if I remember, Volatile Investigation, what's the P? Volatile Investigation, Prospecting Rover or something like that. Anyway, it's going to look for the ice. It's going to go there. It's got a drill, and it's got some instruments to find out if the ice is there, how much. And it is going to be the first rover on another world with headlights, because it has to see down into that dark. But so it's going to be very interesting, and it's battery powered. So it's got to go up to the rim, get charged with its solar panels on the side, and then dive down as deep as it can for as long as it can before the batteries die in the cold, and then come back up again. So it's going to be very strange, very different. The missions to the moon now are going to be very, very different from the ones in the past, because they were in daylight all the time. Here, they're going to be going day and night. It'll be very dramatic when they do get there. So they're also going to build a space station called Gateway, and Canada will be part of that. You can just barely see that the L shape there, the V, that's Canadarm3. So we had Canadarm1 on the space shuttles. Canadarm2 is on the space station. It's up there right now. Canadarm3 will be on Gateway, and Gateway will be in that kind of halo orbit I was talking about around the moon, and it'll be a way station. So SpaceX will dock with that and take people back and forth from the surface of the moon, and Gateway will be around it. Just a couple of other things. Are we going to continue with this? Will the public stay with it? Because the moon missions back in the 60s were great. Everybody was excited about the first one, but they never completed the program because public and government interest waned. They were supposed to go to Apollo 20. They only went to Apollo 17. And the other rockets, you can still see them now. One of them's at the Kennedy Space Center, one of them's in Houston. They were real rockets that were supposed to go to the moon. So will they do this? Well, there's another player involved here, the Chinese. The Chinese are very good at space. They sent a rover to the far side of the moon called U2. First time that's ever been done. We've never landed on the far side of the moon. And by the way, it's not the dark side. It gets just as much light as the front side. It's the far side. It just never faces us. And they have plans to go back. They sent a mission to the moon where they did a sample return. They went there, they got some rocks, and they brought them back without people. So robotically, you can go to the moon and do a lot of exploring. You don't need the people. They've already done that. And there's talk that they're going to send humans there. They haven't done it yet, but they're talking about it. So will this become another race? Instead of between the Americans and the Russians, will it be between the Americans and the Chinese? I don't know, but I think it's going to be very interesting. I don't know if it'll come to this, but symbolically, who knows? So we may be at the beginning of another space race back to the moon. They're going to go to the South Pole. Whether they get there with this Frankenstein rocket or whether they do it with SpaceX, hang around and watch out. It's all going to be happening, and Canada's there. I'm predicting, they say on the second flight of Artemis, there's going to be a Canadian on board. They're not going to land. They're just going to go around the moon and come back. Jeremy Hansen, one of our Canadian astronauts, I think he'll be on that. And so we're there. We've been there right from the very beginning. And so keep your eye on it. And if I can just do one last blatant self-promotion, I have another book coming out at the end of the month called The Future Is Now. It's about green energy. Where are we with green energy? And the good news is there's no new invention needed. It already exists. All the green technology already exists. So I put it all together in this book. It's coming out just the end of September. And maybe I'll be up here giving a talk about that. But anyway, thank you very much for coming out here tonight. I hope we get some clear skies and go take a dome tour and have a look at the moon and Saturn and Jupiter out there tonight. Okay, thank you so much. Okay. Oh, anyone want to ask a question before? I think I'm a little tight for time. Oh, we got 5 minutes. Any questions? Well, that pretty well cleared the room. Yes, sir. Yes, Dennis. Yeah, that's always the question. Do we need robots or humans? And the answer has always been we need both. To me, the robots do the real science. They do the initial reconnaissance. They go there first to lay out the land, sample the soil. We're seeing this on Mars now. You know, there's all these rovers driving around on Mars. And then the people come along later. The people generate the money. The people generate the money. The public, you know, when there was a spacecraft called Surveyor that made the first landing, soft landing on the moon. It barely made the news. But when Neil Armstrong took that first step, the whole world was watching. So the human part of the space program captures the public imagination. NASA is a public organization, so is the Canadian Space Agency. So that gives it the drama, that gives it the role models for young people. And so it has a role there, but the robots to me do the real science. And we got to keep both alive. We got to keep both alive. We can't do one or the other. Yes, sir.
What would be the next steps after prospecting? Are there any plans for permanent habitation?
Yes, there are plans for habitation on the moon. They talk about going there to stay. They will probably have to cover the habitat over with dirt because the radiation from the sun and cosmic radiation is pretty intense. And they will be prospecting for ice. And it's going to be very interesting to see how that works out politically if you get more than one country there. If China's there, if the US is there, and if Russia decides to go there, the ice will be a resource. It'll be the oil of the moon. And so at the moment, there's an international moon treaty that nobody can own it. It's like Antarctica. Nobody owns Antarctica, but you can own your base. So it's mineral rights, you know, and there's ways around that. They do that in well, here in Canada as well. If you're drilling oil, if there's a reservoir of oil, but your land isn't over top of it, they now have ways to drill and make the drill go sideways so they can get in this way and tap into it sideways. So whether or not we'll be fighting over ice on the moon, that's going to be very interesting. But prospecting for ice, there's another resource called helium-3 that can be used in fusion reactors if we ever get fusion off the ground. I talk about that in my book too. Yes. So is the moon an endpoint, or is it leading to something else? There has always been a group of lobbyists who want to go to Mars direct. Don't bother with the moon. We've already been there. Go to Mars. Mars has more of a prospect for life, and it's an interesting world. It's more like the Earth. But the way they seem to be going is, let's do dress rehearsals on the moon. Let's learn how to live on another world. Let's learn how to work there. Let's learn how to deal with the technology, and then go to Mars. So it's seen now as more of a stepping stone to Mars. Because if something goes wrong on the moon, you're only 3 days away from help. If something goes wrong on Mars, you're up to 7 months before the ambulance can show up, or the tow truck with the mechanic if you broke something. So you got whoever goes to Mars has to be homesteaders. They've got to be self-sufficient. And so it's much, much more difficult to go out there. So it's better to get the technology right, make sure that we can work in a very, very harsh environment. The moon is actually more harsh than Mars in some ways. So if we can survive there, we can survive on Mars. So I think that's the plan. Yes. Is it an audiobook? Yes, it is. In fact, I just recorded it just a few weeks ago. It's also an audiobook, and it'll be an ebook as well. Yeah. Oh, Calvin? Yeah. Oh.
But a question, actually 2 questions from Janine. One of those, have you ever been to China for astronomy, or do you plan to be there in the future? And then the other question is, what motivated you to write the latest book here?
Oh, okay. So the first question I didn't quite get.
Do you plan, or have you gone to China for astronomy?
I have been to China, but not for astronomy.
Right.
Now, China was one of the first countries to do astronomy. They have a longer history than anybody. So they're very good at it. But no, I haven't seen astronomical sites in China, no. Why did I write the book about energy? I've been a journalist for years, and I've been reporting on the environment most of my career. My very first documentary I did at CBC was in 1977, and it was about climate change. It was called Running Hot and Cold, because back then there was a debate between geologists who were saying, you know, the Earth's been through 5 ice ages, and each ice age lasts about 100,000 years. Then you get 10,000 years of warm, and then it gets cold again, then it gets warm, then it gets cold. So these warm periods of 10, we've been living in a warm period for 12,000 years. So we're overdue for another ice age. But then the climatologists were saying, yeah, but there's this stuff called greenhouse gases, and they're going into the atmosphere, and they're going to cause it to keep going warm. Well, we now know who won that. I've been reporting since 1977. I was at the Rio 92 Earth Summit, 92. And I keep watching these United Nations conferences saying, yep, we're going to make targets, and they never make them. They never make them. And I keep doing these environmental stories. We're losing the ice in the Arctic. We're losing polar bears. We're losing species. And it's really depressing. And I think, okay, what are we going to do about it? When are we going to finally get off our butts and do about it? What happened to all that green energy that happened after the oil crisis? So I just decided to investigate it. And I'm happy to report that there's amazing things happening with solar. Solar is now cheaper than coal. Solar is cheaper than coal. Wind turbines now are so big, 1 turn of the blade can power a house for 2 days. One turbine can power a town, just one. So wind, solar, it's just amazing what's happening. So that's why I put it together in the book. Okay, tired of the depressing stuff. Yeah, yes.
Off the topic of climate change, but I believe you mentioned that Artemis 2 would plan on the moon to circle it. So what's the point of that?
What's the point of just going to the moon and not landing? We did that with Apollo 8, which was the very first mission to go to the moon and gave us that famous Earthrise picture of the Earth above the moon. That's, you know, was really, really astounding. They do things in steps. We want to know, this test flight is to make sure the technology can work, that it can go to the moon and come back, and that that capsule can survive re-entry. Then we want to put people there. Can the people survive going there and back? And then we'll go down to the surface. So it's all step by step by step, and doing it the safest way. So the mission, the second Artemis mission will be much shorter. They're going to do what's called a free return, where they just go to the moon and let Sir Isaac Newton fly the ship and just use gravity. And the gravity of the moon will slingshot the spacecraft around the backside of the moon and throw it back towards the Earth. So that'll be a very short. So the third one will be launch. One more question. Yes, sir. So the question is, David Suzuki is much more pessimistic. Yes, he is. He believes we're going down the tubes. He's been reporting on it longer than I have. I know David. David and I and Jay Ingram were all good colleagues, and I respect David a lot. David stuck his neck out. David was the one saying, "Look, this is a problem, you know, and we need people out there raising the red flag, saying this is serious. We need to do something about it." I'm more optimistic because I believe that we humans are clever. We got to the moon, for God's sakes. We did that. We did that. And we've done so much with other technology that we can engineer our way out of this. We can figure out how to do it. The technology is already there. So it's not really a science problem anymore. Now it's more of a political and a social problem. And that's not what David and I do. So all I'm trying to do is say, look, it's there, okay? It's there. It's not as difficult, because a lot of people think it's scary. Oh no, we can't do it. It's too expensive. We can't do it. Well, that's not the case anymore. So let's get on with it. Let's get on with it. That's why I'm optimistic. And I want to give young people a future. Say, hey, you know, I don't want to be scaring kids. The Earth's going down the tube, that's their future. I don't want to say that. Come on. We can do it. I just believe that. Why not? Hey, on that optimistic note, we'll leave it for the night. Thank you once again, everybody, for coming.
Hi there. Thanks for the question, Janine. And Amy, can you hear me? And Lori, can you hear me? Can you give me an indication that you can hear me? Hello?
Yeah, you're clear.
I can hear you.
Okay, great. Thank you. All right. So I'm going to tell you about what's up in the sky for September 3rd and for the next few weeks. And we're going to start off with our usual here tonight about sunset, twilight, and sunrise. So sunset is now earlier than 8 p.m. and it's at 7:50 p.m., 14 minutes earlier than last Saturday. So civil twilight ended at 8:22 p.m. and at the end of civil twilight, you should be able to see the first stars. So you're able to start seeing stars at about 8:22 today, and nautical twilight ends at 9:01 p.m. So coming up fairly soon, and astronomical twilight ends at 9:43 p.m. and so that's about as dark as it'll be until moonset. Astronomical twilight resumes at 4:42 a.m. and sunrise is 6:35 a.m. tomorrow morning, so 11 minutes later than last Sunday. And so that means we have almost 7 hours of full darkness tonight, not counting some city lights, which I'll talk more about later, and moonlight. So sunset was around 9:29 on the summer solstice, meaning that the sun sets about 2 hours and 39 minutes earlier now than it did then. And we had 16 hours and 6 minutes of daylight versus 13 hours and 17 minutes of daylight today. So that's a difference of almost 3 hours. And so while it still feels like summer in the daytime, with the warm daytime temperatures, hot, in fact, daytime temperatures lately, summer is definitely on the way out, it's definitely dwindling. So the moon currently is about 53% illuminated. So first quarter moon occurred just earlier today where it was 50% illuminated, and it sets at 11:15 p.m. And note that the major moon phases this month are right on weekends. So this happens to be on the weekends at this point. So first quarter is today, and full moon is next weekend. And the moon is a little bit to the left of the star Antares, and close to the star, close to the point in the sky where we look to see the direction of the center of the Milky Way. So if you're like this at arm's length, hand side, and about halfway up on your fist, the center of the Milky Way would be sort of down on the other side of your fist and near your bottom finger. So if you're just trying to get a sense of where the center of the Milky Way is in the sky. Okay, so equinox is on the 23rd, so that's coming up fast. And as for the planets, Saturn rose at 7:09, and I'm going to see if I can get stellarium going here. I should have had it up. Just bear with me for 2 seconds here. And hopefully I'll have it up here in a second. And we'll just swap over to it. So here's stellarium. And so there's the moon, there's Saturn. And so it rose at 7:05, and Jupiter rises at 8:38, so any minute now. And it's at opposition on September 26th, and that means that that's the time when the Earth is kind of right on a line between Jupiter and the Sun. So Jupiter is in the opposite direction from the Sun. Mars rises at 11:03, and just a little bit to the north of east. And Venus rises at 5:22 a.m., a little bit later each morning. So twilight has already started, so it's going to get lost in the twilight glow pretty soon. So I'm just going to stop sharing this window and just maybe share a different window. I'm going to share the space weather site. And this is one of my favorite sites. Very interesting to see what's going on with the sun. And there's been quite a few aurora visible, different parts of the north over the past week. And if you're wanting to get a sense of whether you're going to see the aurora at night, there's this auroral oval down the left-hand side of the page. And when that is pretty much over top of the island, then that's you should go outside and look for the northern lights. So that's kind of a handy way to look for that. And there's this great photo gallery here where you can see some of the latest photos taken of the sun and also the northern lights. All right. So I'd just like to talk a little bit about something else, and it's a light pollution survey. And so earlier I talked about the amount of full darkness outside of moonlight city lights. So what about those city lights? We know that artificial light can affect not only our view of the nighttime sky, but also our sleep and also animals, insects, and plants. So it affects really the entire ecosystem. And so you might wonder, well, where on Vancouver Island, for example, can we find a spot that's completely unaffected by city lights? And I'm going to see if I can show this map here. If I can bring it up, and well, it might be hard to do here. Shoot. Well, unfortunately, I can't seem to bring it up on the screen, but it turns out that they're only up near the north end of Vancouver Island is it really completely away from city lights. And that's actually because there's just so much city light from the larger cities on the island of Vancouver that it's really hard to escape now. And we know this because somebody actually used some satellites to actually look down on the Earth and actually measure the amount of sky glow in different areas. And they found that there's just a few regions up there that seem to be completely unaffected by that. And I'm just going to see if I can actually bring up something else here. And wish me luck here. But about 11 years ago, the local center of the Royal Astronomical Society of Canada did a survey of the nighttime sky. And this actually involved a lot of the dedicated members of the center, including Sid Sidhu and David Lee and others. And these little dots that you see here represent the sky brightness. And so you can see here that it's actually, aren't really any green areas or black areas, which would indicate that we're really completely free of light. And the red and white areas are where there's a lot of light pollution. And for this study, what they did was they took out a little light meter, actually not so little, but when it's in its casing, but it's really about the size of a TV remote control. And they pointed it straight up and pointed it at different locations in the sky, and actually directly measured the sky brightness from looking up. So unlike what I was talking about before with the satellite looking down, these dedicated cameras went around and the sky brightness. So how actually bright is the sky, and what kind of effect does that have? I'm just going to stop sharing here again, and then reshare Stellarium. I think I showed why I couldn't clear visual. Try again with that in just a minute. And here's time sky. You can see Jupiter coming up there, and we have the moon. And we should be able to see the Milky Way, but we can't see it. So let's have a look here. And what I'm going to do is I'm actually going to change the amount of light pollution if I'm successful here. And you can actually see right now, with it dialed all the way up, you really can't see much of anything. You really can't even see the brightest stars. Maybe the summer triangle, and that's about it. So if you're in downtown Victoria, that's about all you can see. And so there's some areas in Victoria like this, but and then out here where I am near Hillside Shopping Center, I think it's about a 5. And this is approximately what I see in the nighttime sky. And you really can't see the Milky Way cutting through there. I know it's there, but you really can't see it. And if we had really good light pollution laws and so on, and shielding on all the lights, this is what we might be able to see in the nighttime sky. So light pollution really does affect our experience of the nighttime sky. And so it's going to be really interesting to see what happens. We're just in the planning stages of this renewed survey right now. David Lee is leading it, and so we hope to get some results before too long. And I'm just going to take another crack maybe at sharing that other visual, if you can just bear with me. Yeah, I think I might be able to do it here. And giving a presentation, I go, I want to be like that, but I don't think I'm ever going to be quite as good as Bob McDonald. So hopefully you can now see this light pollution map. And this again was done from using a satellite and looking down on the Earth. And so you can see how terrible it is over in the eastern part of the United States. And it's just one big mega city essentially. And over here you can see Vancouver Island. We're going to zoom in just a little bit more. And we're starting to see the bottom of the island now. And I'm just going to, zoom in again. And let's see if I can move things around just a little bit. And so, lost it a little bit. Having a little bit of a problem here, juggling windows. But you can see that down here is Victoria, and it's pretty much lost in a big sky glow. And then there's only a few areas up here in the northern part of the island that seem to be completely unaffected by light pollution. So let's see what we get when we redo this survey after 11 years. So I think I'm going to stop my presentation there, but I'd just like to remind everybody that we're a volunteer-run organization, and we do rely on donations of different types. We love it if you join up with this, because that really sends a message to the government and to funding agencies that people care about what we're doing. So please consider becoming a member. And also, don't forget our gift shop, because that helps us out too. There's always, and I see Amy smiling because she loves it when I mention the gift shop. And so what do we have, Amy? Anything? cool that you want to highlight out of the
Well,
gift shop this week?
you're putting me on the spot. We've got some
Yes, I
new
am.
lunar memory games, which are quite cool. And we have more of the line of the Celestial Buddies, and we have a plush Polaris that lights up when you squeeze it.
Oh,
It's very cute.
well, my birthday's coming. I might ask for that. So, okay.
But Dawn, there are a couple questions, and I have a question as
Oh,
well.
sure.
But Janine just was wondering about the geographic scope of David's project.
Mm-hmm. I think it's probably going to be the same as the last time. I'm going to stop sharing and go back to the RES. This is something we're actually debating right now as to whether to do exactly what was done the last time. And here, I'm going to reshare again. Sorry, I have to keep jumping back and forth like this, but I should probably work on my Zoom skills, shouldn't I? Yeah, here we go. So this is the absolutely incredible map, or one of them that the RESC did back in 2010. And you can see it's really the Greater Victoria and Souk area. And that's a lot of points. That's a lot of observations. So at every single one of those points, somebody was there out in the dark, probably getting cold with one of these light meters and getting readings. And what we're actually talking about doing now too is also doing visual observations using the so-called Bortle scale, where we go, well, how many stars can we see? Can we see the Milky Way? And writing that number down first, making that estimate, which is actually that number that I was changing in Stellarium, 1 to 9, and then making the digital measurements and comparing the two. There's also, we had some discussion today about taking direct photos of the sky, because that's a lot easier to do now with digital cameras and fisheye lenses, and you can actually directly measure the glow across big areas of the sky. But I mean, this has to be doing so, and has to be affordable. So in terms of time and actual equipment expense, so we're really talking about the logistics. One thing that is of great interest now, because we do know that this is light pollution is tied into the ecosystem, is maybe we should actually be focusing on wetland areas. For example, what's in nesting areas, like what's the light pollution like in some of these wetlands and so on around town. And so we're all discussing that, and so we're going to probably be talking to some biologists and so on. Are there any migration routes that we need to be aware of, that, like within this geographic area? These are some really interesting questions that we can maybe talk about and maybe talk to some researchers about before we implement it. But we're yes.
Can I interrupt?
Sure.
Okay.
Hi, Laurie.
I just say that each one of those dots was done through taking the SQM meter readings about 3 or 4 times over about a 10-minute period. So you had to keep, and then we averaged them, and so that it wasn't just one reading that we were taking and then moving along to the next group. It did take quite a bit of time, because at each stop you had to kind of take these readings at a certain place, and we had to even put down on the charts like whether there were any lights in the way that we didn't realize there might have been, was there anything else that was happening, like all that kind of thing we had to do. So it doesn't look like a lot of dots, but in fact it did take quite a bit of time.
It looks like a lot of dots to me. So it's just an amazing piece of work, and that's great methodology to take a few readings and average them. That's good scientific methodology, because you never know, maybe one's crazy, right? Maybe the first one is there's one green little star up by the airport. I don't know whether you can see that. It's right up in there. Yeah. And I actually took that one because I remember it like it was really amazing. I didn't even realize until we got back that was actually that it did so well. And it was in a little area that is outside of the airport, like a little bit between the airport and Sydney. That there were some trees around that we took it, and so that when I put the
SQM meter kind of up to the top, and you know, kind of as you do. I think that some of the light pollution from the airport area that I thought was going to be quite a lot was actually shielded a little bit, and we got this great dark sky up there. Only that one. I went farther up. I did some of the others up on top of there, and even then we didn't get even farther away from the airport. We didn't get as good reading. So it was interesting.
Yeah, there's one just north of Brentwood Bay that I can see on this particular map. I know there's other maps on the RASC site, and I do encourage people to also consider joining the RASC and definitely check out their website.
Yeah, we would even be able to have people just help with the survey. Like, you
absolutely.
Can just simply help out with the survey would be great.
Yeah.
So.
Yeah.
So,
yes. Another question or
Yeah, I have a question. So I recently have spent some time with some friends on the Sunshine Coast. And one of the great things about Sunshine Coast is every night you wait for the Milky Way to come up. It's so lovely. And then this time it was kind of what's going on with the sky? And I guess because there's always been that light pollution halo from Vancouver, but now the light pollution is increasing so much in Nanaimo that you can no longer really see the Milky Way every night, which is amazing that they could. But the question I have, and I wasn't quite sure how to direct them, is they were like, how do we make this stop? Like, we like seeing the sky. Yeah. What can the average person do in order to kind of stall off the light pollution?
Well, I mean, I think always with these kinds of issues, it always starts at home. Like, don't leave your outdoor lights, string lights on all night long to mess up the view of local view, which contributes to local sky glow for your neighbors and for any creatures trying to sleep in the trees or around your yard or something like that. There have been a couple of things happening, like the lighting standards have been improving in terms of having more lights with shields on them and so on, but LED lights have become so inexpensive that they've really, especially the blue ones and so on, they've proliferated, and so people are using them and just letting them run all night long, and so that has actually made things worse. And so I think it comes back to responsible lighting and awareness and communication, and just try to I don't know, it's like so many environmental problems, it takes a lot of steady effort and trying to get reasonable people educated and on side. There's always going to be unreasonable people who won't listen, but there's lots of, I like to think there's many more reasonable people out there who, once they hear what's going on, they will actually want to do something about it. And I just changed this David Lorenz's satellite map here just a little bit so you can see where the Sunshine Coast is, and I think it's right around here. Yeah. And so this was done in 2020, and so let's just dial up the light pollution to see it. And yeah, sure enough, you can see that dark band of green reaching out from Vancouver, and we'll give Nanaimo some of the blame too. I like to blame Nanaimo because I grew up there. So also the fires that, like, there has been smoke in the air in the past couple of weeks that just has given us sunsets, but it also is a bit smoky, and you can't see some of the things with that as well. So that's a fantastic point. Yeah, it's the amount of particles in the air and so on. And this is something that David and I were talking about a week or two ago, saying, well, what are we going to write down in terms of the conditions? Because humidity might be a factor, whether you're in a valley or not. I mean, you might just, because you're in a valley, there's going to be more local moisture and ground fog and things like that. So there's a lot of things to take into account to make this a really robust type of measurement. And it's a big undertaking. I mean, it almost sounds like another full-time job, like we don't have enough with our day jobs and our FDIO full-time volunteer job. Yeah. But I think I will find some way to, I think, do it in a reasonable way and try to at least get some comparison with that brilliant survey the local center did back in 2010.
Yeah.
Thanks a lot,
Mhm.
John, for bringing that up. Really
Yeah.
important. Yeah.
Are there any other questions? Anything from the from YouTube or no?
Let me check. Sorry.
Checking.
No.
Nothing from YouTube.
No,
Okay.
no.
All right. Well, thanks a lot, everybody. And as I like to
Thanks.
say now, keep looking up, and we'll see you next time.
Thank you.
On the 24th.
Right.
Yes.
Okay.
Yes.
Bye.
Thanks.
That was fun. Thank you. Okay. Good night.